Hi everyone. Today we're going to look at the IXL. It is D5, identify rational and irrational numbers. So this is what you should see on this IXL. In this question, it says, is 3/4 a rational number? And you're just supposed to say yes or no. Okay. Be careful with this assignment. It's very important that you're reading each of the instructions for each of the questions. Some questions might ask if it's a rational number, and then some questions might also ask if it's an irrational number. So it's very important that you're deciding if they want a rational number or an irrational number, and then that way you can look at that number and decide if it is or it's not. Okay, let's go ahead and take a look at some things to keep in mind and maybe some examples. It's important to look at the definition of rational and irrational numbers. Okay, so with rational numbers, these are going to be any number that can be written as a ratio of A over B, where A and B are integers and B is not 0. So as you can see here, we have A in the numerator, 0 in the denominator. This can't happen. You can have 0 in the numerator and a number in the denominator, but you cannot have 0 in the denominator. You can write whole numbers as rational numbers. You could take a whole number. So we have the whole number 2, and you can write this as a fraction or a ratio between the two and say 2 over 1. Irrational numbers are going to be any real number that is not rational. Okay, they are irrational. In decimal form, all irrational numbers are non-terminating and non-repeating. For instance, some examples of irrational numbers could be pi. Okay, could also be numbers that are not perfect squares. So perfect squares mean that you find the square root of the number and you get a whole number. Numbers that are not perfect squares are numbers that you'll end up getting a very big decimal for the answer once you find the square root of that number. So let's take a look at a couple of examples now that we've kind of gone through the definitions of rational and irrational numbers. So this is an example right from this assignment. It says, is 1 a rational number? And my question for you to consider with each of these questions is, for starters, we want to make sure that they're talking about what they're looking for in this question. And in this case, they want to know about rational numbers. So we're going to go back to this definition and say, okay, well, 1 can be written as a ratio. We can always say that 1 over 1 is the same thing as 1. So since it can be written as this ratio, we would say that yes, the whole number 1 is a rational number. Okay. Looking at this example we have, is 10.970 a rational number? Remember too that rational numbers, and I'm going to add this over here, are terminating and repeating decimals are included in this. Okay, so if the number has a decimal that terminates, so it ends, then it's rational. If you have a repeating decimal that's going to repeat the same number or numbers, then it's also rational. Okay, so in this case, we're looking at 10.970, and we want to know, is this a rational number? So considering that this is a terminating decimal, it does end after, you could say it ends after 97. You can also say it ends after 970. There are no numbers past the 0. Okay, so we would say that yes, this is also a rational number. Okay, what about this one down here? And this is the symbol for pi. We want to know, is pi a rational number? However, when you consider that we've talked about pi before and pi is an irrational number, we would say that the question is asking us if pi is rational. So we would say, no, it is not rational. Okay. Then you get down here to this question. And again, these are just some examples of stuff that you'll see on this assignment. we get this question that says, is 44.13 repeating? This is the symbol for repeating. Is this an irrational number? But again, if we go back to this definition of rational numbers, we would see that terminating and repeating decimals are rational numbers. So 44.13 is a rational number, which means that it cannot be irrational. So we would say, no, it is not irrational. Okay. And then we get down to this question down here. We're finding the square root of 25. Okay. Now, if we solved this, if we looked at finding the square root of 25, what number could we find that's going to multiply by itself to give us an answer of 25? We could say, okay, so 5 times itself would give us 25. So we would say that the square root of 25 equals 5. Which, looking at this, once we solve for the square root, we actually get a whole number. And we know that whole numbers can be written as ratios over 1. And so we would say, yes, this is a rational number. Okay. Some other examples that you're going to see on this Excel include the following. So some of the questions, when you get into those harder questions, the challenge questions, the 50 SMART score, 60 SMART score, you're looking at these questions to say, which of the following is a rational number? So we're looking for a rational number, and you're going to do the same thing that we were doing before, but instead of having one number, now you have multiple numbers to look at. Okay. You can figure out that the square root of 97 it's not a perfect square. So this is actually going to be irrational. Okay. You can also figure out that the square root of 51 is not a perfect square. So this is also going to be irrational. And then we know that pi is also irrational. So looking at this question, this answer choice, we have a ratio of 73 over 62. Our denominator is not 0. It is an integer. So we would say that this is the only rational number out of this group. Okay. So you're going to do the same thing, like I said, that you were doing with those questions where you're looking at one number, but now you're going to look at all of them and you're going to decide, you're just going to read the instructions. If they're looking for a rational number, you're only going to pick out the rational number. If they're looking for an irrational number, then you want to pick out that irrational number. For instance, the next question, which of the following is an irrational number? Okay. Well, looking at 0, okay, 0 is, it's not positive, it's not negative, but it is on the number line, okay? And you can actually write, 0 over 1, and you would just get an answer of 0, okay? Same thing with negative 24. We can write this as negative 24 over 1, and then 1/2 is already written as a ratio. But then you look at this number down here and you can see that the square root of 30, okay, thinking about that, finding the square root of 30, it's not going to give me a whole number. It's going to give me a decimal. It's not a perfect square, okay? So we would say that this one is, and I'll circle it, this one is the irrational number, okay? What about this one? Looking at this one, which of the following is a rational number? And again, anytime you see where it asks about rational numbers and then you see pi is not going to be your answer, okay? And then you want to look at square root of 40, okay? Square root of 40, thinking about that one's not going to give you a whole number. Same thing with the square root of 71. When we've reduced those, finding the square root, okay, those are not going to be rational. This one, even though it's written as a whole number and a fraction, it's still written as that ratio. Okay, you can actually convert this to a fraction by multiplying the denominator by the whole number and then adding the numerator. So we would get 13 plus 12, which would be 25 over 13. And that's going to show you that it's that ratio. So we would say that, yes, this is a rational number. And then one other kind of answer choice question you might see with the answer choices is something that looks like this. Now, with these questions, these are a select all, okay? So this is where it's important to make sure that you, these symbols will tell you which ones you have checked, and you want to look at that and say, okay, you know, there might be multiple answer choices. They all might be the answer choice, or there might just be one. In this case, this question wants to know which of the following are irrational numbers. Okay, so again, you're going to do the same thing we were doing before, but now you're going to check all of them and you might have more than one choice. We know that pi is irrational, so we can just go ahead and click that one. Okay, now we look at the square root of 26. We know that 26 is not going to give us that perfect whole number. Okay, so we know that this is going to be irrational. 48 can be written as a ratio, 48 over 1. So this is not going to be irrational because writing it as that ratio is telling us that it is rational. And then 9.37, it's a repeating decimal. And with repeating decimals, those are rational. So we would say this is not irrational. Okay. I want to just go ahead and put the definition back up for you to see. And then that way, if you have to, if you want to pause this video and just use these definitions, okay. So rational numbers are any numbers that can be written as that ratio or that fraction, as long as 0 is not in the denominator. Rational numbers also include terminating and repeating decimals. Irrational numbers are going to be any real number that is not rational. So if you can determine that it's not rational, it's probably irrational. And then in decimal form, all irrational numbers are non-terminating, so they're never going to end, and non-repeating. And just to kind of show you a fun example, pull over the calculator so you can see that. If we go ahead and click this pi symbol, okay, it's going to give us this long number, and pi goes on forever. Okay, so even past this 5, it's still going to continue on. This is just the most space that the calculator has. So you can see that none of these are not repeating numbers, and it doesn't end. So that's going to mean that pi is irrational. All right, well, thank you for watching this video. Please reach out if you have any questions at all.